Just wait for 1 minute so that I can adjust the setup of it. So welcome in class. Today we will out uh, purine metabolism or degradation of purine. When we think about the degradation of purine, there is a factual thing is there when we think about the duration synthesis, and as we study IMP, that is metabolism or of that stuff. Just purine as is but no of degradation. Degradation nucleotide nucleate. Basically, the first one the adenosine is present. Nothing can say that here one. Then specifically here, and that is nothing but that it is next is known as adenosine monophosphate. So adenosine phosphate, but we can say it is wrong. So adenosine monophosphate can form a IMP, that is inosine monophosphate. Structure wise difference in the inosine monophosphate is nothing but we can say it will carry oxy keto group at the 6th position here, and it will have same as that of structure, that is ribose 5, and here it is a double bond, here it is H. So this is nothing but IMP, that is inosine phosphate. What will happen? It is nothing when we thought the degradation of purine or that AMP, degradation of the purine along with AMP, that P and IMP. These are adenosine monophosphate, inosine. It will have the purine will have second carbon, the 8th carbon, and at the 6th second carbon, 8 one, and carbon we have also keto group, and is known as acid. That is known as acid. We have another group 2, 6, 8. Itself can convert to inosine monophosphate. See what is the difference 2 and O? So nothing but adding monophosphate deaminase reaction. So inosine monophosphate. This monophosphate is formed, and then it is nothing but a reaction. So left here, ammonia is left in the form of ammonia, and molecule is incorporated in this. So first reaction, it is nothing but we can say adenosine monophosphate. This will convert in monophosphate. This is in the presence of kinase reaction. This diamine reaction convert adenosine monophosphate into inosine monophosphate. That what we can say happening, and there is nothing but the presence of EMP deaminase, and 2O is converted to amino group. Another pathway is also can say removal of specifically we can in the metabolism, say wall is nothing but can say H nucleotide nuclease, and it converts is a sugar. This is tied, and when it is an impulse, so it will form, that is nucleoside, and this side is what we, it will have ribose sugar. It does not bond is here, double bond is here, double bond, then N ribose base, it will this right over into RP, nothing but what is the difference between the AMP and MP? Only it having a amino group and here having a group, but it has been, and the adenosine monophosphate can convert so can convert into adenosine. So adenosine monophosphate convert to adenosine. This is the presence nucleotide NH2 and phosphate mode evolve this way. Nothing but only it is both 5. So in the presence of nucleotide, same reaction. Presence of nucleotides. This required H added and identified. Easily made. Nothing but nucleoside. Nucleoside means what? Sugar. Base plus sugar, and that is known as a inosine. So known as a inosine, depend on the station or first, but the correct pronunciation say here. So here it will have as it, then he having a nitrogen, and place of ribose 5 phosphate it will have only sugar. So it will having a double bond here, double bond here, and it will have the H. So very important is what you should know the previous structure. Depend upon that you can draw the easily the next structure. So these three structures, that is nothing but adenosine monophosphate, inosine monophosphate, and I will also draw the third structure is guanosine monophosphate. Now what is the difference between the inosine monophosphate and guanosine monophosphate? It is nothing but it is nitrogen, same as first and third position. Then here it is also at this position it is having a nitrogen. Here it is one, and this nothing but it will have the keto group here and amino group. Here it will be NH. And it is known as a GMP, that is guanosine monophosphate. So very important is what guanosine monophosphate is also metabolized and same structure. This first reaction will be similar for all, and further only the inosine monophosphate and GMP will go for the degradation. AMP directly converted adenosine. So to remember only is very easy. I'm telling you, it is very easy. You might be thinking it is a difficult, but if you know the structure, then it is very easy. And how to remember the structure? See, all basic ring is similar. So is a adenosine monophosphate. So next is inosine monophosphate. How to remember structure? MP you can remember. Now convert to IMP. IMP how can remember? Cis amino group, and this double bond automatically the valency will not be created, so that's why it double went off. And the G, how the difference? Same as it is of IMP plus only amino group will be present at the second position. That is that, and that is nothing but no GMP. Now GMP also will undergo the reaction the present nucleotides, and this nucleotide nucleus and nucleus known as guanosine. And this is nothing but guanosine, and this is nothing but required what? Water it is required, and it is required inorganic phosphate it's get evolved from this. So ribose 5 phosphate convert into ribose, that's all. The remaining will be same as it is, so you just draw the tweak. And I'm telling you, please practice with me only so that you can remember easily. Here double bond will be there, here the double bond, here it is nothing but O, and here it is H, and here it is nothing but ammonia. So here we got inosine and we got guanosine. You please me so can get it easy and I can start. Now it is been, so I will begin. Inosine monophosphate. This inosine monophosphate further into adenosine. This adenosine monophosphate further converted into adenosine, that is a nucleotide converted into sugar moiety. Nucleoside means what? Sugar moiety along with the base. here the base adenosine monophosphate you can able to remember is not nucleotide is an enzyme and it is nothing but H2O converted into PI inorganic will get relieved and adenosine is formed. In monophosphate it will have the difference O keto group instead of amino group and double bond will be not present, and this in the presence of nucleotidase it H2O converted into PI and that is nothing but inosine, it is nothing but a nucleoside it is forming sugar molecule, sugar and base. Then along with that monophosphate, this guanosine monophosphate difference is what? Double bond O and amino and here. So guanosine monophosphate and this guanosine phosphate can convert into guanosine and that is nothing but a nucleoside, that is sugar and base. Sugar and base. So this is nothing but we can say it's been in the so first reaction is a base that is nucleoside nucleoside and nothing but in the present nucleotide into inorganic phosphate is AMP convert into P and AMP phosphate monophosphate by kinase by deaminase, nothing but this deaminase. And otherwise another pathway is what? Adding monophosphate nucleotide can convert into nucleotide convert into nucleotide in the presence of nucleotidase and H2O can convert into PI, that is inorganic phosphate, and there is nothing but adenosine is formed and IMP also in the presence of nucleotidase H2 inorganic phosphate is removed and there is nothing but inosine is formed. But in the aspect is you this adenosine form inosine and there is a formation for guanosine. So further in the reaction, the inosine and guanosine is an important. What about adenosine? So here inosine again deaminase, deaminase that will convert adenosine deaminase that will convert adenosine into inosine. And that nothing but 2O is nothing but here it is required and NH4 is nothing but UOL. So first of all very important aspect is here reaction A can convert into IMP, otherwise adenosine can convert into inosine. This is nothing but the state. Adenosine monophosphate can convert into IMP, that is inosine monophosphate, and adenosine can convert into inosine and that inosine further go for the degradation. So here there are particularly we can say there are chance and guanosine monophosphate that can be converted into uric acid. But in the reaction inosine or inosine and guanosine further will continue the degradation, but adenosine can convert into inosine. So adenosine will not directly convert into uric acid, it will convert into inosine first and that inosine undergo degradation to form a uric acid. So after this we will concentrate only on the inosine and guanosine. So I guanosine as a specially present. Here it is present double bond and here nothing but a ribose sugar. And then what about the is it not clearly visible? So please I will just see it is it visible? Please send me anybody send me message that is visible or not. Those who are online, please send me reply me that it is visible or not. So inosine is nothing but form. This inosine is nothing but we can say inosine and guanosine. These are nothing but two form. This inosine and guanosine. So please reply me if it is not visible. I hope now it is visible.